Hi friends, today I'm going to make a video about how to rewrite a paragraph, and I'm going to take a paragraph from one of my writings and then I'm going to rephrase this entire paragraph. So this is like an example which tells you how to reduce or to minimize plagiarism in a particular document. I'm Dr. Ranjan Ganguly. Now let's take a look at this paragraph from a paper published in Journal of Sound and Vibration in 2002. And you can see that this is a typical paragraph which you will find in many journals. And this paragraph essentially summarizes certain aspects for a problem in vibration, but it essentially deals with certain aspects of mechanics, response surface methods, computation, and so on. Now, if we look at the paragraph, we will see a lot of technical words. For example, the fact that we are using polynomials to create response surfaces. These response surfaces tend to filter out noise, which are often present in numerical simulations. They also simplify the integration with optimization codes because these are smooth functions. The problem of numerical noise, we touch upon that. That sometimes takes place because convergence is not complete in many methods. And generally, these type of problems are present in numerical methods which have iterative solution procedures. Now, numerical noise creates problems with gradient-based search methods because they have local minima which may be spurious, and response surface is one more way to smooth out these numerical noise and local minima problems. Now, you also have low computational cost with response surfaces because these tend to take less computer time and so on, and therefore you can use computationally expensive strategies such as genetic algorithms, exhaustive search methods, and so on when you are using response surface methods. Now, one of the issues in response surface, of course, is that if design variables increase, these methods become difficult to use. This is also known as the curse of dimensionality problem. And also, finally, we mentioned that there is an excellent introduction to response surface methods, which is found in a particular reference, this being Montgomery and Meyer's book. So now this is just a typical outline you see in a research paper. And now let's say you want to rewrite this paragraph such that most of the phrasing is different and it reads different, but it essentially communicates similar information. So let's look at how to do that. So what I would do is I would break this paragraph up into sentences. So this is what I have done here. I have broken this up into sentences, and we see that there are about 10 sentences here, and these are the main content as far as this paragraph is concerned. Now what I do here is I take these 10 sentences and I have highlighted in red what are the important keywords for the problem. And this is just a tool to see as to what is the main concept which is being told in this problem. So we can see very many aspects here that response surfaces are being used. These are essentially polynomials. They filter out noise in numerical analysis. Numerical noise is not a good thing. It can lead to spurious local minima for gradient-based methods. So we can filter out noise with response surface methods. Also, response surface methods have low computational cost, which makes it easy to use for genetic algorithms. However, the problem becomes somewhat intractable if the number of design variables is large. So that's the main crux of the problem, and as power of computer grows, this problem is also getting mitigated. So that's the basic concept here. And now what I'm going to do, I'm going to take a couple of sentences at a time, maybe two, three sentences, and going to rewrite this paragraph. So let's start with the first two sentences. Now, here I have seen clearly that response surfaces are lower degree polynomials. They filter out noise in numerical computation and simplify the integration with optimization code. So now after I read these couple of sentences a few times, I essentially rewrite this in the form which I have given here in the blue letter. So what I write is that response surfaces are typically lower order polynomials which can remove noise from numerical simulation. So I've taken some content here, I have mixed it with content in the second sentence, and I then add that response surfaces are easier to integrate with optimization codes as they are often simple functions such as polynomial. Now here I use a word here, more over. These are actually good transition words. There's one more word like furthermore. You can use these words to take a particular concept and add something more to that concept. So these are often useful in technical writing. Now we take the next two sentences which essentially talk about numerical noise. And what they say is that numerical noise is present and that these often come from certain aspects of the numerical solution such as iterative solution process, discrete representation of continuous geometric shape, and so on. So I now rewrite this in this form here in terms of three sentences. So it's often better if you have a large sentence to split it into two sentences, which we try to do here. So what I write is that numerical noise can occur in the results of numerical methods which use iterative approaches. So here you see I mix up some of the aspects of these two sentences. Then I use one more transition word like furthermore. Then I say numerical noise is created through discretization of the solid and fluid domains. So this is essentially what I'm mentioning here in terms of fluid flow, geometric shape and all. I've given it a more concrete or different representation here. And then I do bring out the fact that these numerical noise issues come from certain high frequency perturbations in the numerical result, which indicates the presence of numerical noise. So that essentially captures the basic thing behind these two sentences and essentially rewrites it. We continue further with the same theory. I pick the next two sentences here, and here the main concept is that numerical noise tends to create spurious local minima which cause problems for gradient based search methods. And therefore response surface methods are good because these will tend to smooth out these noisy functions and filter out numerical noise. So I rewrite this in the blue here. So I add a transition word, for example, unfortunately, and this gives us some feeling to the sentence. So the fact is that gradient based methods can get trapped in spurious local minimum points which are created by numerical noise. Now, response surface method can not only reduce numerical noise, but also permit us to create approximations of the computer model, also called meta models or surrogate. Now, here I put in something which I know and which I have learned from some different place that essentially what is happening here is that certain concepts called meta models and surrogates are being created. So this is my new input to the problem, and I have also generalized this fact to computer models in general. So again, this is just a rewriting of these two sentences. Now I take three more sentences here, and essentially these sentences bring out certain aspects such as low computational cost of response surface methods. These are useful for certain algorithms which take a lot of computed time. And we also see some negative aspect of response surface methods, that the computational demands tend to grow as the number of design variables goes up. However, we know that with the power of computers increasing day by day, this problem is also decreasing. So I rewrite this in blue here. So I say, since response surfaces are computationally efficient, so essentially that word is capturing the fact about lower computational cost. We can use global optimization methods such as genetic algorithms and exhaustive search. Typically, such global optimization methods are computationally expensive and difficult to use with computer models. However, response surface methods become more expensive to generate as the number of design variables increases, a phenomena also known as the curse of dimensionality. The problem is decreasing with the increasing power of computers. So essentially, I have digested these three sentences after reading them, and I have rewritten this in this form here, where I communicate the same information, but I have changed the writing to certain extent. Now, finally, I'm left with one sentence, and so I just rewrite this sentence. So, by saying that instead of the reference 15 going at the end, I just say reference 15 provides information about the response surface methods. So now I put this whole thing together, and so this is what I have now. Now, I could leave it right here, but that would not be a good thing to do, because as researchers, we always spend more time on something and we try to polish it. So again, it's like, you know, if you are polishing something, you need to do a good job for it, because then the things become better. So I'll just write this whole paragraph like this here, and then we'll look at it further in the next few slides. So here I go through it and I say, let me change some of the wording. I don't like the wording. So when I start looking at this paragraph, I see remove noise. So maybe I change the word here to eliminate. I see easier, and I can say response surfaces are straightforward. I see occur in, so I can say numerical noise can materialize. Maybe I'm sending this to a US journal. I am therefore turning all the words from British English to US writing. I'm putting the Z here or the Z here in place of S, which is used in the UK writing. Now I see here a sentence which doesn't look so good to me. Response surface method can not only reduce. So I use a word from my vocabulary, that is abate, which is essentially if something is bad and is becoming less bad. So I use that word here. And again, I don't like this use of too many words here. So I again replace this by and allow creation of approximations. I see here the use of the word we can use easily. I try to make it more formal. I say that response surface methods are amenable, which means they are easy to use, but in a more generalized manner. And then I take one more large sentence here, that expensive and difficult to use with computer models. And I use the word onerous, which of course means difficult or burdensome. So you don't have to use all this vocabulary. I'm just showing a way to actually use vocabulary to reduce the number of words. And also you are changing the entire way the paragraph is written. So you are essentially making this whole paragraph different as far as any accusation of plagiarism or something like that is concerned. You are taking it in a different direction by adding all these words. Finally, I change is decreasing to reduces, because is decreasing is not a good usage of language. And finally, I don't think I need detailed here, so I put more information. Now, again, I can stop at this point, but then why not spend a little bit more time? So again, I have rewritten this out here, and let's make some changes here. First of all, I feel this references 15 sentence is not very useful. Maybe I can just dump this sentence and move 15 here, because I know reference 15, Montgomery and Myers book, talks of response surfaces as lower degree polynomial. So I just put it here and I get rid of this sentence here. Now again, these red are signifying some of the words I changed before. Now, some of the wording is somewhat passive, and also I make it more direct here. So I write computationally efficient response surface models are amenable. Okay. So again, now I have a somewhat more crispier write-up, and this I would say is a good final write-up. So this is what I select. And here what I have done finally is I have rewritten this paragraph to a large extent, and I think it looks quite different from what I started out with. Now, this is also useful if you are taking a particular concept and maybe taking a piece of information from your old paper and writing a paper one more time. You cannot just take that paragraph and reuse it, because that again becomes the problem of self-plagiarism that will also get flagged by any software such as Turnitin or some of these softwares, and it will come out as something that's being used here. So again, now to a large extent I have changed this paragraph. It doesn't mean it's completely different, but it's quite different. you want, you can work more on it. I was just trying to show you the process of how we can take a paragraph and we can rewrite it. And I have used some interesting words here. Now, again, you don't need to know all these words all the time. Many of these words can be obtained from Google by just searching for a particular word, and it will give you thesaurus based words which are similar to this. And if you want to improve your vocabulary, certainly you can check out my playlist on the different words I have put up, the English words to know, because many people think that when you have exams like GRE or GMAT, it's just some weird person out there who has put this plethora of words for you to learn. Actually, one of the uses of these words, which I later found out when doing research, is that you can use it in your writing, and by using somewhat more complicated words which give you a better meaning for the problem, or which give you a different meaning of the problem, you can sometime change the language, and therefore you can have less problem of plagiarism in those cases, as well as enjoy the process of writing, because you will start feeling a certain love of words and you will become somewhat of a logophile, and therefore you will start to really like the art of rewriting things, writing things, and so on. So this was my take on how to rewrite a paragraph to minimize plagiarism, and I hope you benefit from this video, and I will see you sometime soon in a new video. See you then.